Good day, guys. This is Teacher Patrick. Today we're going to look at radioactivity, specifically nuclear radiation, Chapter 11, Unit 2 and 3. Okay. I hope you enjoy this lesson. Please leave questions if you don't understand anything. Okay. At the end of today's lesson, you should be able to describe the detection of alpha particles, beta particles, and gamma rays. Discuss the random nature of radioactive emission, and identify alpha, beta, and gamma emissions. Okay, so first, to understand radioactivity, we need to look at something else. First, we need to look at something called isotopes. Okay, so isotopes of an element are atoms that have the same number of protons but a different number of neutrons. So if at the bottom of the page you'll see that there are two oxygens. The one has 16 particles and the other one has 18 particles. The fact that both of them are oxygen means that they both need 8 protons. The first one has 8 neutrons and the other one has 10 neutrons. So the second one, or both of these, would be called isotopes of oxygen. Okay, so you can remember isotopes as obese electrons. Okay, so isotopes have identical chemical properties because they have the same number of protons and the same number of neutrons. Some isotopes are unstable and decays, giving off either a particle or a burst of energy, also known as radiation. Okay, so that's where the radiation comes from. Now, firstly, we need to look at stability. What makes elements stable or unstable? Now, any element from element 1 up to element 82 are usually unstable unless, and you'll see at the bottom, there are more protons than neutrons. That makes them unstable. Or if there's significantly more neutrons than protons, which would make them unstable. But most of the elements from 1 to 82 has either equal number of protons and neutrons or a reasonable amount of neutrons, slightly more than the protons, which makes it stable. Then you will see any element higher than 83 automatically becomes radioactive, and that is unstable. Okay, so to understand radiation, we need to understand how we detect it as well. So here is a piece of a rock of uranium which is highly radioactive. Okay, you would not be able to see that with your naked eye. So the question is, how do we identify radioactivity? Ionization of air. When radioactive particles or rays go through air, okay, they knock the electrons out of the air molecules and they transfer it from one molecule to another, leaving the air ionized, positive and negatively charged. Okay, so we use that effect of radiation using this device called a Geiger tube. You'll see at the end of the cable there's a tube, and inside this tube it measures the ionization of a gas. In this case it uses argon, so the radiation knocks the electrons out of the gas, leaving the gas particles positively charged, and the electrons would move to an electrode inside the GM tube. Therefore it creates an electrical potential difference which we can measure simply like we measure the voltage over a cell. Okay, so types of radiations, guys. There are 3 main types of nuclear radiation. The first one is alpha particles, then beta particles, then gamma rays. Okay, so gamma rays are not particles, they are bursts of energy, and we're going to look at all 3 of them now. Alpha particles, okay, or alpha decay, is firstly when we have atoms or any element higher than 83, which becomes unstable because there are too many protons that repel each other. So the solution is it emits an alpha particle. As you can see at the bottom, an alpha particle consists of 2 protons and 2 neutrons, decreasing the total amount of protons in the element. This changes the element to another substance, to another element. Okay, and it also, you'd see that they call the alpha particle a helium particle because it's similar to a helium nucleus without any electrons. Okay, so here we see an atom. The atom is the nucleus is unstable, so it emits 2 protons, 2 neutrons. That packet of 4 is a alpha particle. Next, we have beta particles. We get beta at positive and negative decay, but in IG we'll just look at beta negative. Okay, so beta negative decay is when there is significantly more neutrons than protons in a nucleus, which causes it to be unstable. The solution is the atom turns a neutron into a proton, increasing the amount of protons. When this happens, an electron is emitted and a particle called an antineutrino that we'll look at later. So here we'll see that the one green dot turns red and it emits a blue electron. Okay, so the neutron turns into a proton and emits an electron. So a beta particle is an electron. Last, we'll look at gamma rays. Now, gamma rays is not particles. What happens is after an atom has emitted alpha or beta particles, it has an excess of energy. We call that state an excited state. Okay? And then what happens is it emits excess energy in the form of a gamma ray or a gamma ray photon. It's a burst of energy. Okay, now guys, last but not least, we need to understand that this radiation is random and spontaneous. Random meaning it can happen at any given time. There is no way to predict which atom. If we had to line up 100 atoms, we would not be able to predict which one would emit the radiation first. Okay, and secondly, it's spontaneous by nature, so it means that we will not be able to influence them. We cannot heat them up, we cannot cool them down, we cannot do anything to that particle to force it automatically by itself to emit radiation. So it happens by itself and it's impossible to predict. That's what random and spontaneous means. I hope you have a better understanding now about the topic, and if you have any questions, feel free to leave them at the bottom. Have a nice day.